Hi everyone, this is going to be a short video on solving equations with complex solutions so that you can use these examples as models when you have to do some examples like this in a problem set. We haven't covered the topic of solving equations with complex solutions together in class at this point in time. We may cover it at the beginning, but if we don't, this will be your introduction and work actually with it. I'm going to show you an example that looks like this. X squared plus 16 equals 0. Now, this is a quadratic equation. It's a quadratic equation that has two terms. The first term is the quadratic term, and the last term is the constant term. In this quadratic, what's missing is the linear term. There's no term that just has an x. When we have that situation with a quadratic equation, in order to solve it, we can make it pretty straightforward. We don't have to go through a big factoring approach. We don't have to go through a quadratic formula approach or anything like that. We can make our life a lot simpler by just taking the constant and moving it over to the right-hand side. When we do that, we'll subtract 16 from both sides, and we get this. X squared is equal to negative 16. Now, in order to solve this, we have to undo the x squared because we just want x for our final answer. So I have to square root both sides of this. When I take the square root of x squared, I end up with x because the square root of x squared is x. X times x will give us x squared. So I get x equals, when I work in an equation being something that has an equal sign in it, so our equal sign, I have to take the positive and negative answer of my numerical piece. The square root of negative 16, though, deals with taking the square root of a negative number. And we just learned that we can take the square root of a negative number by pulling the square root of negative 1 out of it and multiplying that by the positive value that would be left. We know that the square root of negative 1 is equal to I. So x is going to equal positive or negative I times, and in this case, the square root of 16 is a whole number, I times 4, or x equals positive and negative 4i. So those quadratics before that you were getting no solution to because you couldn't work with them, we can now solve all quadratics. These are going to be special kinds because they don't have the linear term, and the approach to solving them is going to be pretty straightforward by just moving the constant over to the other side and then square rooting both sides of the equation. So we might have to look for some greatest common factor factoring from time to time, but if we miss it, I think we can go about solving it in a fairly straightforward way. What if I give you an example like this? 4x squared plus 20 equals 0. Now, I can approach this a couple different ways. Let me go through and do one version over here, and then I'll show you what happens in another version. 4x squared plus 20 equals 0. If we take the approach I just took with the other problem, I'm going to move the constant, the constant value to the other side by subtracting it. The smartboard is not cooperating. So I have 4x squared equals negative 20. Now we're trying to solve for x, but there's a 4 in front of the variable piece here. I'm going to divide both sides by 4. X squared is equal to negative 5. And at this point, I'm going to look over to my other problem, and at this point I took the square root of both sides. This is a 5. The square root of x squared is x, and I know over here I need the positive and negative root of the square root of negative 5. That's going to get broken into negative 1, the square root of negative 1, times the square root of positive 5. We know that the square root of negative 1 is I, so positive or negative I. And I can't simplify the square root of 5. I'm going to leave it just as is. My final answer to this problem with this approach is x equals positive or negative I radical 5. That's one way. Now, some of you may look at 4x squared plus 20 equals 0 and say to yourself, I recognize there's a greatest common factor in this quadratic equation. So I'm going to pull the 4 out of each of the terms. That leaves me with x squared plus 5 left over. At this point, I would divide both sides of the equation by 4 because I want to isolate the piece that has the variable in it. That leaves my equation as x squared plus 5 equals 0, which is really kind of headed in the same direction as I was before, but I don't have that 4 involved anymore. I'll subtract 5 from both sides because the rule is with a quadratic that doesn't have a linear term, we can just move the constant over to the right-hand side. X squared will equal negative 5. And we're right at the same point we were over there. So I'll take the square root of both sides. And this will leave us with x equals the square root of negative 1 times the square root of 5, which is going to turn into I radical 5. What did I forget here? Someone should be yelling at me. I forgot the positive and negative symbol. Oops, this is not calibrated well. But you know, it should have the positive and negative like the other one had in front of it. So these are two examples that will help you go through the problem set that involves solving equations with complex solutions. Of course, if you have any questions, you can always come see me too. Thanks.